Hey, 7th graders, we are ready to start Unit 10, which is all on circles. Minnesota says, looking at the unit goal at the bottom of this slide, I can use proportional relationships, areas, and circumferences of circles and sectors in a real-world situation. This lesson is just going to cover 3 basic parts of a circle and then how 2 of those 3 parts are related and create a relationship that gives you a very special number. Let's make sure we have these materials out: your Unit 10 note packet, pencil, and a calculator. If you need to get your Unit 10 note packet, it is in the Unit 10 folder on Schoology. Pause the video and come back when you're all ready with those materials. Today's lesson goal says, I can show an understanding of the relationship between diameter, radius, and circumference of a circle. Area is a topic we're going to come back to at a later time. Let's fill in the first part of our notes with these 3 basic parts of a circle. We have radius, which is represented by the variable r. And radius looks like this on a circle. Go ahead and draw that. Now let's describe that with words. A radius is the distance from the center to the outside edge of a circle. So it touches the center and it touches the outside edge. As a reminder, pause the video anytime you need to finish writing. Next, we have diameter, which is represented by the variable d. Let's draw and illustrate what the diameter looks like inside a circle. Now let's describe it with words. The diameter is the distance all the way across a circle that goes right through the center. Do you notice a similarity between a radius and a diameter? They look similar, don't they? Yeah, and we're going to pop back over to radius and fill a little bit more information in our notes here. Radius is half of the diameter. Fill that part in. Do you see where my cursor is? Fill this in as well. Radius is half of the diameter. If you haven't caught on, be writing what these 3 important parts of a circle are as well. You'll see them identified in my color text there. Next, we have circumference. Circumference is a really fancy word for perimeter. It is the distance around a circle. So we want to write that as distance around outside edge. It's what we call perimeter. When you found perimeter of polygons back in 6th grade, perimeter of a circle is called circumference. Say that out loud once. Circumference. Yeah, and it's represented by the variable c. Make sure everything that you see in front of you is filled out in your notes. So you might want a fun trick or a way to remember the difference between radius, diameter, and circumference, and it can come from the length of the words themselves. Radius is the shortest word. It's the shortest measure. Diameter is longer. Circumference is the longest. So you could use the length of those 3 words to help you remember how they show up in a circle. If you want to fill this information in the left-hand side of the first chunk in your notes, go for it. All right, we're going to fast forward ahead here in our notes. We are going to get to what is pi without an e, but what I want you to do right now is flip to the back of your 10.1 note. We just went over 3 basic parts of a circle: radius, diameter, and circumference. So how do you find radius and diameter? Well, we wrote a special note next to radius there at the end. Radius is half the diameter, so we're going to use that. Looking at our circle example here, we are given a segment that goes through the center and it touches both sides of the circle. Would that be radius or diameter? That would be diameter. So the diameter measures 50 millimeters. We know that the radius is going to be half of that. So to calculate that, we can go 50 divided by 2, which is going to give us 25 millimeters. Feel free to use your calculator at any time. Looking at the next example, this time we have a segment that just touches the center and then goes to the outside edge. Is that radius or diameter? Radius. So radius is 17 centimeters. The diameter then, if radius is half of the diameter is going to be another 17 centimeters that I need to add with the given 17. So I can go 17 times 2 to give me my diameter, which is 34 centimeters. So to get that diameter, I took my radius and I times it by 2. So this right here was my radius. And this over here, I'm going to back it up, was my diameter. Looking at the next example, this time we don't have it filled in our circle, but we're given this key right here. This segment, which is given by the variable r, is equal to 1 8/10 of a centimeter. This, we know radius, the variable r represents that. So my radius is given here, it's 1.8 centimeters. I know that my radius is half the diameter. So if I want to get the diameter, I need to double the radius. So to get that, I'm going to go 1.8 and I'm going to times it by 2. Again, this is my radius. So 1.8 times 2, that gives me 3 6/10. And it's being measured in centimeters. Looking at our last example, we can see that we're given a segment that's it's cutting the circle in half. So that means we are given our diameter. So D equals 5.2 centimeters. We know radius is going to be half of that. So we can go 5.2 divided by 2. And remember, this right here is our diameter. Radius is half the diameter. So 5.2 divided by 2 is going to give me 2 6/10 centimeters in length for the radius. So again, radius, diameter are important parts of a circle, and they are related to each other. Radius is half of the diameter.